Welcome to Cornerstone Home Inspector Education Center. Tonight, we have a combined presentation. Stan and I will be presenting load-bearing walls and beam identification. Um, Certificates, just a couple of notes. Certificates will be emailed to everybody tomorrow morning. If you do not get a certificate, please look in your junk folder first. And then if you don't get it by noon, email me. It was sent out and got lost, and we'll resend it to you. As always, take a look at our calendar of events so you can see what's coming up. And if you have any questions, please feel free to unmute yourself. If you're not talking, keep your microphone muted, and you can chat in the chat box if you have any questions. So we'll get started. We always start off with our state standards, and most of the state standards for the states that we're in are the same. We have them all here if you want to go back and read them, but basically in Connecticut, what would apply for today somewhat a structural system, the inspector shall inspect the structural components, including foundations and framing. You're going to want to probe a representative number of structural components where deterioration is expected or where clear indications of possible deterioration exist. Probing is not required when probing would damage any finished surfaces or where no deterioration is visible. You're going to want to describe the foundation and report the methods used to inspect underfloor crawl space or basement area. For newer inspectors, that means you have to say, I went in or from the scuttle, put it in the report on how you inspected it. The floor structure, the wall structure, the ceiling structure, and the roof structure, and report on the methods it used to inspect the attic. The inspector is not required to provide any engineering service or provide architectural services. And this goes on for, we're not going to read them all tonight because we got a long presentation to get through. Rhode Island, New Jersey, again, you see foundation floors. You're going to want to put the foundation construction type of material. It's all the same, just worded differently. Same thing with New York and Massachusetts. And again, you could just go to your state standards, which we have on our site under links of interest. Each state standards there. So if you lose them, want to download them, they're right on our site. So tonight, the course overview, the foundation of safe inspections, why this matters. Identifying structural elements is the bread and butter of every professional home inspector. Understanding load-bearing walls and beams protects homeowners from catastrophic failures and ensures you provide reliable, safe, focused evaluations. Tonight, we'll reinforce your ability to distinguish between structural and non-structural elements, recognize unauthorized modifications, and report findings with confidence and precision. So it's important to know what we look for. And I know as when I do inspections, it's usually the wife that will look at you when you're standing in a cape or a ranch going, can I take this wall down between the kitchen and the living room? So it's we'll give a little bit of guidance on that and as we move forward. Learning objectives tonight, load transfer. We want to understand how loads move through the structure from the roof to foundation, wall identification, distinguish load-bearing walls from partition walls using proven inspection techniques. Hazard recognition, identify structural alterations and potential safety hazards during field inspections. Accurate reporting, document and communicate findings using professional liability protective language. Why it matters, risks, real consequences. Unsafe renovations involving wall removals can represent one of the most dangerous modifications homeowners can undertake without professional guidance. When load-bearing walls are removed or compromised without proper structural support, the results can be significant, from sagging, progressive structural failure, to possible collapse. As a home inspector, your ability to identify these issues protects families and prevents costly, dangerous failures. Every year, thousands of homes suffer structural damage due to unauthorized wall removals, undersized beams, or improper load transfers. Your trained eye stands between a safe home and potential disaster. We're going to go through a lot today or tonight, but I can tell you I've walked into, it's not many, but I've walked into a few houses where I walk in and I see a wall removed And I remember a cape I did in Rocky Hill that all the cabinetry for the kitchen, in between the kitchen and living space, was falling down and tilted. They had removed the load-bearing wall, and the ceiling was deflected significantly. So it's something that we want to really pay attention to. Codes and standard reference, International Residential Code. R301 design criteria establishes minimum load requirements and safety factors for residential structure. R502, floor construction, governs size, joist sizing, spacing, and bearing requirements. R602, wall construction, defines bearing wall requirements, stud sizing, and header specifications. These code sections provide a technical foundation for identifying proper structural elements. While home inspectors don't enforce codes, understanding these codes help you recognize deviations and potential safety concerns. Engineer framing concepts often supersede prospective code requirements when stamped by a licensed professional engineer. If you are viewing this as a pre-recorded event, your viewing code is LBW 7367. Give some time now. Okay, so what types of loads are there? We have dead loads, the permanent weight of the building structure itself, including framing, roofing, drywall, flooring, and fixed fixtures. These constant loads are factored into the initial design. That's called a dead load. Live loads are temporary and variable weights from occupants, furniture, and other movable objects within the structure. Building codes specify minimum live loads per square foot based on room usage. An example on that is I had a house that had a dining room that was turned into a library. And when I went into the basement, 3 or 4 of the floor joists had snapped because of the weight of the books. And they had put, I mean, it was not a big room, maybe an 8 by 10 room, but there must have been 5,000 books. I mean, it was ridiculous. So we had to make a recommendation for additional structure to be put underneath that because that room was handling way more load. And that's a live load because the books can be removed. Wind loads, lateral forces generated by wind pressure on the exterior surfaces of a building. These forces are calculated based on geographic location, building height, and exposure conditions. Snow loads, the weight accumulated from snow and ice on a roof. Regional snow load maps guide minimum design requirements to ensure roof structures can safely support this variable weight. And I can tell you, I was sitting in my sunroom, which was an addition to my ranch probably 15 years ago. And we had a big storm. Then we had another big storm, and I didn't clear the snow off the roof. And I hear a pop, and the sheetrock that was installed in between the old and new structure just snapped and just put a line down it. So I should have removed the snow load because it was just not handling. Point loads, concentrated force applied at specific isolated locations, such as from posts, columns, or heavy equipment. These necessitate specialized structural design consideration. Load path concept, roof structure. Loads originate at the roof surface, including shingles, sheathing, and then the rafters or trusses supporting them. Okay. Ceiling joists, horizontal members like ceiling joists collect and transfer these loads to the supporting walls below. And you can see a diagram here, the downforce and how the load is spread across the building. Load-bearing walls, vertical load-bearing walls composed of studs channel the accumulated loads down through the building's floor system. So we see here an example of non-bearing, your roof truss. There's a bearing beam, support column, and your outside load. This is a load-bearing wall here, here, and here. So all this downforce, this is again, all the downforce is going to the sides and to the load-bearing walls here. Beams and girders. Large horizontal beams and girders efficiently span wider areas, distributing loads between crucial foundation points. You go into some of the capes and some of the ranches will have steel I-beams as their main support girders. So you do not need as many lolly columns because they're able to support more load with less support underneath them. Foundation. The foundation is the ultimate destination where all structural loads are safely transferred to the underlying soil. All right, vertical versus lateral loads. Vertical gravity loads, forces acting downward through the structure. These include dead loads, live loads, and snow loads, which we've talked about. Vertical loads compress the structural members and require adequate bearing surfaces. Lateral loads, horizontal loads, forces acting sideways on the structure, wind and seismic forces create lateral loads that can push, pull, or rack structural elements. So again, vertical gravity is forcing downwards, lateral horizontal is sideways. Why load path understanding matters. When the load path is interrupted through wall removal, cut joists, or missing supports, forces must redistribute. The redistribution can overload remaining members, causing progressive failure. Understanding load paths allows you to trace forces through the structure and identify where modifications have disrupted the intended design. Every structural element serves a purpose in a load path. Load transfer through framing. This visual representative shows loads through systematically from the roof through each structural element to the foundation. Notice how the bearing walls align vertically across the floor and how beams span between support points. Understanding this continuum path is essential for identifying comprised structural systems during the inspection. So again, we have roof framing, we have our ridge member here, our roof sheathing, everything's forcing down to the foundation. We have headers that are having support on them, ceiling joists. You can see how this path is going all the way to the foundation. Identifying load-bearing walls. Exterior walls are usually load-bearing. In conventional construction, exterior walls typically support roof and floor loads. They form the perimeter bearing system that transfer loads from above down to the foundation. General rule, assume exterior walls are load-bearing unless you observe evidence to the contrary, such as engineering truss systems or steel beam framing that bypasses the wall. Exemptions to consider. Gable end walls and simple truss systems may be non-bearing above the ceiling line. Curtain walls and post and beam structure only serve as weather barriers. Walls below overhangs may not carry upper floor loads. Steve, did you want to take over now?
Sure. So
okay.
I want to make a point that I'm going to say 99% of the time when we're doing a home inspection, we're really not going to see all of the framing in the living space. So if the basement is unfinished, that's the best place to determine or start to determine where the load path is. All right, by looking at the number and location of the main girders or supports, things of that nature. So if you walk into a house and you see this, I don't think we're going to see that too often. We won't be able to determine the size of headers and things of that nature. There's other things to look for, and we're kind of going to get into that from this point on here. So next slide, Jim. So how to tell if a wall is non-bearing. The wall should be parallel to the floor joist. If it runs perpendicular, it's likely a load-bearing wall. It should be interior walls, not exterior walls. Walls that form the perimeter of the structure are almost always load-bearing, as we said before. It should be thinner than 6 inches. Load-bearing walls are generally built with lumber thicker than 6 inches or stronger materials. Should not have purline bracing. If purline bracing is attached to the top of the wall, it is a load-bearing wall. Be supported by other walls or joists. Partition walls are secured to other structures in the building, but are not designed to support the structure. And not be masonry walls. If the wall is made of concrete, brick, or blocks, it is most likely load-bearing. It's not to say that somebody can't build a
Sod.
modified masonry wall inside the house, but that you're starting to add weight, something has to support that as well on the interior. Interior walls, reading the clues. Central interior walls running perpendicular to the floor joists are strong indicators of a load-bearing function. These walls frequently divide the structure into sections, providing critical support. Examine the construction. Load-bearing walls often feature larger studs. Example 2x6 instead of 2x4. Double top plates and continuous headers above openings, signifying greater structural capacity. Again, you're probably not going to see a lot of this or recognize it right off the bat. Verifying alignment with the structure above and below. If an interior wall aligns directly with beams in the basement or crawl space or actively supports upper floors, it's highly likely to be load-bearing. And that's, if you see something in the living space, cracking, things of that nature, sagging, the basement, if unfinished, or even when it's finished, sometimes you might be able to get an idea. Don't forget, we do not have to do any of this. If you think there's an issue, you just pass it on and in your report to either have it further evaluated by a contractor. You have to determine how serious you think it is and what category you're going to identify it as. Okay, Jim. Joist direction is your primary clue. When joists run parallel to a wall, that wall typically does not bear load from those joists. The wall may still support loads from above floors or roof structures. And the picture on the left, there would likely be walls above that girder, and the joists are running perpendicular to the wall. If you can see that red line where it says not good, if there's a wall above there, it depends on the size of the joist or what type of floor system that is. There may be some, the closer to that beam, the stronger the joist or the I-beam or the floor framing will be. And closer to the center is where you're going to notice most of the drag. So this is your strongest visual indicator in the basement. Okay, that's fine.
Okay.
Multi-story alignment in general. Load-bearing walls typically align vertically across the floors. This alignment creates the most efficient path and minimizes structural complications. When inspecting, note walls that stack floor to floor. These alignments strongly suggest bearing function. Pay special attention to offset walls or interrupted bearing walls, as they require beams or other structural compensation to transfer the loads. Missing or undersized beams at these locations represent serious safety concerns. In a two-story house, I don't think I see much modification on the second floor unless they open up 2 small bedrooms to a larger room. I think most of what we're going to see is probably in older homes and on the first floor.
All right. So this is all load bearing here, Stan. This,
yes,
the foundation here, but anything within here, if you had like a wall right here, wouldn't be.
Wouldn't be.
All right.
Normally.
Correct. Oops. Sorry.
So you can also use the attic space for clues. The directions of the ceiling joists or rafters reveal potential bearing walls. Walls perpendicular to these members often carry structural load. The ridge and roof support identified bearing walls or posts supporting the ridge beam. We're going to talk about that in a couple slides. These crucial elements transfer significant roof loads downward. truss systems. Engineered roof trusses are designed to bear primarily on exterior walls, often eliminating the need for interior bearing walls. That's why when you are working with trusses, in most cases, you don't have to worry about where you put walls or if you have any walls at all. And double joist, the presence of double or triple joist frequently signal concentrated point loads from above, indicating a bearing wall or beam below.
Just to step in, one of the things that I'm really cautious about when I'm in an attic is to check the roof structure right here to make sure everything's nice and tight on the main beam. Now, I'll come in and I'll see some houses where maybe 2 or 3 are cut short or pulled a little bit. I usually will just take some pictures, not a big deal. But if I'm seeing 4, 5, 6, 7 of them pulled away, that can be a problem. Then I'm pulling in other aspects or windows and doors opening. Is there any cracking ceilings and walls? But this is at least for me, is a much important part of my inspection right here, especially if there's problems in the house.
This is a bit repetitive, but when a wall runs perpendicular to the ceiling joist, it means the wall sits in a 90-degree angle to the direction of the ceiling joists are running. Why does this matter, especially for us as home inspectors? A wall that runs perpendicular to ceiling joists is most likely to be load bearing because the joist can rest on or transfer a load to that wall. This is not a guarantee. Inspectors still have to verify the load path, structures above, below, spans, beams, etc., but it is a stronger indicator. The simple way to visualize it, imagine joists running east to west, a wall running north to south crosses them at a right angle. That's perpendicular. Okay. So again, basement inspection clues. You want to note where the beams and girders are located, and interior walls above typically align with these main support members. So I do outside first. Excuse me. I do the basement first. After that, on the inside, and then I go up through the house. At that point in time, I have an idea already of where I think any load-bearing wall should be positioned. The thicker sections of foundation wall may support bearing walls, and for floor joist direction, confirmed bearing walls are orientation above. The basement provides the clearest view of structural load paths. Take time to correlate what you observe below with wall locations on the main floor. This correlation is critical for identifying bearing walls and potential structural modifications. So if you look at this picture here, we have these load-bearing beams in several different areas. There would be no reason to build like this if we weren't carrying a load on top of these. So this is something you may see. The chances are when you get above this space, you're going to see a wall located over these beams. And in this case, they're posting down with steel alley columns to the foundation. This is a similar, if reading this picture, it looks like the main girder is offset from the left. We're stopping here at this load there, and then it begins 2-3 feet behind there and goes to the rest of the way across the basement. And they are supported, not something that I think I would call this out, just built up wood columns going down the floor, and they're just nailed together. Probably never be a problem if the basement was dry as a bone, but I think those are better served by at least the steel alley column in that case. But
Had them everywhere else.
At least there's a path. So here is a ridge beam, and this is a larger home. I have some personal knowledge about older capes that I'll bring to your attention in a minute. So this beam is being supported or taking the load from that beam down to probably the foundation with that stacked up column there. And probably below there, you'd see those two little headers are windows. So that's maybe an attic, maybe an unfinished space that's intended to be finished, but that might be something you won't see during your inspection. But that is the load path carrying the roof load and then spreading it out to the sidewalls. So that might go straight down to the foundation. Okay, Jim. Here's a kind of funky. So the load path from the ridge beam is brought down to a header, which is supported by those 5 built up support columns. And then there really isn't much header for the rest of the windows. Now, my question would be, how is that carried to the floor below? If you look way at the bottom of that picture there might be a substantial plate across there that might be suitable to support all that. But again, unless you walk into a building with no sheetrock up there, you may not be able to see this. I think, well, I'll show you in a couple slides what you may see. Shims, under today's IRC-based standards, a main load-bearing girder must have full solid bearing, at least 3 inches on concrete or masonry, and any wood placed between the girder and a pier must provide continuous flat support, not wedges or stacked shim. If wood is used in contact with the concrete, it should typically be pressure treated or otherwise protected from moisture to reduce decay risk. Best practice is for the girder to bear directly on the masonry pier or on a steel plate with non-shrink grout to ensure uniform load transfer. Loose, uneven, or untreated wood blocking under a primary beam is generally considered poor practice and may warrant correction or further evaluation. So I learned this early on, observed it a couple times. So let's say you have a 1940s cape with a ridge board. It would spread the load to the exterior walls, and the window in the gable end would have a header, and maybe not even anything to carry that ridge board to the header or to the load to the foundation. And then they decide to put on a dormer. Sorry about the drawing, guys. So ideally, you would take that ridge board and make it a ridge beam and post it down to you'd beef up the window header, you'd post down across on the either side of the window, and then probably even across the doorway, say whatever's underneath there on the first floor. And then you would pick up the load of that dormer roof, because that dormer roof is on a different angle now. It's going to have a different load, so it's going to need a little bit more support. I will tell you that a lot of times they just built the dormer off of the ridge board. So if you can go to the next page. So what you can't see was the load path modified. All right, Jim. So this is what you may typically see if that dormer wasn't built properly. Cracking around the windows. Those are significant cracks. That might be all that happens, but that might be an indication that that dormer was not installed properly. You may even see a little sag if it's still a ridge board instead of a ridge beam in the dormer roof itself. You would probably notice that first if you're doing the roof first, and then you get inside and you see this, and this could be a backup. If you were concerned about a sag in that dormer roof. But I have seen this several times. Non-bearing partition walls, they're thinner construction. You know, in 37 years, the only time I've seen thinner wall construction, we have Aunt Sonia here in Connecticut that had a lot of kit homes. They were 2x3 steel frames, but usually it's 2x4s with single top plates indicating they carry no load beyond the wall's own weight. The partition walls can easily be relocated during renovation without affecting structural integrity. No beams or additional support required. Most partition walls, again, run parallel to floor joists and show no joist bearing on the wall's top plate. Truss systems, engineered design. Engineered roof trusses represent a game changer in residential framing. These factory-built components distributed loads through their triangulated web design, typically eliminating the need for interior load-bearing walls. The entire load transfers to the exterior walls. When you identify a truss system, interior walls are generally non-bearing for the roof load. However, they may still support upper floor loads in multi-story construction. Always verify the complete load path. But they are very good, especially in a ranch one floor home where you can have no walls, put the walls any place you want. You don't have to think about it. So laying the house out is a little different approach.
Stan, we may have a question.
Yeah.
I don't, Liz, if you have a question, you would hit a marker to ask something. I don't know if you want to ask.
Yeah.
Go ahead. Sure.
I do have a question. Stan, could you expand on the distinction you made between a ridge board and a ridge beam and its impact when you have a dormer? Could you just talk a little bit more about that?
Jim, can you go back to the picture of the ridge beam?
Thank you.
You're
This
welcome.
one?
No, back. There.
Okay.
So if you look at that ridge, it's a 4-ply, right? There's
Yep.
4 they're
2x8s.
probably 2x6s, 2x8s, and so it forms a beam, and the depth of that ridge beam is actually determined by a few things, but also the span, because there may not be anything underneath there in the center. A ridge board, in a lot of instances, is one
Yep.
board running across the
Just
roof.
one.
Okay,
Right.
now you probably won't see ridge boards in houses built, say, after the 80s, maybe. But older ranches, capes, especially old beach cottages, sometimes they didn't have any. Sometimes those rafters were just butted against each other and nailed off. So in those buildings, and I'm going to expand upon that, I call that in those cottages, I call that cottage style construction, because generally all that construction is under frame and overspaced, right? 2 by 24 inches on center.
Yeah.
And they all going to sag someplace. They all have this, they're still bringing a load down somewhere, but probably inadequately.
And Liz, if you go into a real old home, you may see some of these boards overlap with just a peg through them, or nothing. They just might be just abutting each other on on older homes. Go ahead, Stan. I'm sorry.
So that's why if you're doing the outside first and you notice any sagging in the roof, in the entire roof, there are a couple things that could be happening, but you'd want, like Jim said, look at the support of the roof and determine if it's a ridge board, just single board, or a ridge beam. And the beam is much stronger. They still, at least today, they need to be engineered to carry the load over the distance, but I don't think you'll see any more ridge boards. There's a lot of things you won't see anymore in new construction, and we're going to get to that in a little bit as well.
So Stan, is it the case that a ridge board, I mean, it's just not doing anything structural? It's just keeping the rafters in alignment?
Correct.
Okay.
Yes, if you want to boil it down to that.
Yeah.
It's giving the rafters someplace to rest.
Yep.
And bear the load. So the load's going through the rafters themselves, and the ridge board is there to kind of hold them in place and hold them together.
But you're not getting that support down on the side.
Correct.
Got it. Okay.
Correct. But you got to post down with the ridge beam to carry all that load. Sure, absolutely.
Thank you.
You're welcome. Did I do this already, Jim?
Yep. No, truss. We're on truss. Well, I think we did. We know about truss.
Yeah.
So let's go on. Let's go to here.
So renovation clues. Again, you're not going to walk in. Well, you're less likely to walk into a house and have all this open. But you may be able to identify taped off areas that might have been opened, where behind there might be cut studs, missing top plates, or already altered joist configurations that compromise the structural load. Again, we probably won't see that. We might have to look for other clues to determine that. Patch drywall. You know, if they didn't do a good job, sometimes these patches stand right out. I think we've all seen those. And then you go, especially in ceilings, well, was there a roof leak? Why was that patch? So what I do is I note all these things and then kind of add them up later and see what I think they may mean. Headers without support. Wide openings with headers lacking visible support posts or beams often signal unsafe structural alterations. So you should have, you don't have to have a solid header. There's a couple ways to build them, but solid header, that header should go beyond the jamb and have a couple of studs there, a jack stud, a king stud, to bring that load down to wherever it's supposed to go. And then sagging or deflection. If it's visible in ceilings or floors, especially near renovated areas, that may indicate insufficient structural support. Mismatched materials, mismatched lumber sizes, incorrect metal hangers, or temporary supports like jack posts suggest structural changes needing evaluation. So for us as inspectors, keep your eyes peeled. So as I kind of alluded to a couple minutes ago, newer or more modern construction would tend to have less chances of having major remodeling because they are already incorporating open floor plans, modern styling. However, it has been my experience that older homes are more likely to have had floor plans changed in major updates. So if you think about, I'm going to say from 50s, 60s, even 70s ranch or cape, they're very simple. If you look at the diagram in blue, they usually they're cut up with walls for living room space or dining room and bedrooms. You know, the kitchens, you enter the kitchen, you can't really see through anything. The basement stair goes down next to it. That's the way we built houses. They were divided into a lot of rooms, capes, ranches, even colonials. Okay, Jim. If you look online and you see the outside of the house, or you walk up to that house, it's a 1950s ranch, and then you walk inside and you see this, then for me, the first thing I think of is there were changes made here. Some kind of renovation went on. And today it could be the flipper. It could have been people who purchased an old house and decided to remodel it right off the bat. So I automatically am thinking, I got to look around for evidence of, you know, was it done properly as best as we can tell. And I always have a blanket statement when I see floor plans changed, footprint of the building changed. Was a permit pulled for renovations, and was it approved by the local building department? You might see things that look like correct modifications of structures, and you may pick up on things that look unsafe, or maybe not so much unsafe, but improper. You have to use your own knowledge on that, and you have to feel comfortable with your call. You don't have to go very far in saying if it was done right or telling them it's not done right and this is how you do it. You just bring it to their attention in a report that it may not be a proper renovation. If somebody comes up with a permit and says it was done with a permit and approved by the city, then I would probably not take it any farther, but we may never hear that. I don't think everybody calls back after an inspection and say, oh, by the way, Stan, I got that permit. I think they just move on with the sale. But I think most people can tell when an older house has been modified because they never really had open space. And that's a big, desire now. Beams and girders, structural horizontal support. Beams and girders are large horizontal structural members that span between support posts to carry loads. While the terms are often used interchangeably, girders typically refer to larger members that support other beams. These critical elements allow for open floor plans by spanning long distances and transferring loads to posts, columns, or foundation walls. Recognizing proper beam installation and identifying deficiencies is essential for structural safety assessment. I don't know if you can, I think you have to see something that you think is a problem before you can determine if the beam size is proper. You won't determine it, but if you can question it, let's say that.
I've gone into some ranches where I go in, and it's the idea, if you've done 4 or 5,000 inspections, or even 400 or 500 inspections, and you see a main girder in the basement that looks like this, you're probably okay. But I've gone in and I've seen them 4x4 with a tree trunk underneath. It's like, that's not going to cut it today. So you got to call that stuff out. If it doesn't look right, it's probably not.
So we're talking about load paths, but the deeper, taller, whatever you want to call a structural member, whether it's a beam or a floor joist, the stronger it will be, the longer it could span. I can almost guarantee you, and the species of wood also determine. So if there's a chart, and if you were to, at least in older homes, if you were to say have a piece of spruce and it tells you it can go 12 foot 6 inches without any support and it's a floor joist, I'm going to tell you that they're going 12 foot 6 inches on that. So if you've ever walked through a dining room in a older house, at least me, because I'm kind of bigger and a little probably heavier than a lot of you guys and gals, and they have a china cabinet, and I'm walking through that room and everything is shaking and vibrating, it doesn't mean the floor joist is underspanned or undersized. It means that I'm walking right down the middle and I'm testing the span of that. You'd have to go a size up to kind of minimize that, or put a support underneath it. That's
Right.
probably not going to happen if you want to open basement space. But so the same thing with the girders, and beams, they'll sag. I don't think it's a huge thing, but it's probably not the best way to handle things. Dimensional lumber, traditional solid wood beams, often triple 2x10s and 12s, are cost effective, but have limited span capacity because you got to splice them. I think I see that most of the time. An engineered wood product, LVL, offers superior strength and consistency, easily recognized by its layered appearance and typical 1 3/4 thickness. The PSL parallel strand lumber is engineered lumber, consists of wood strands oriented parallel to its length, providing excellent strength and dimensional stability. And then, of course, we have the steel I-beams. Steel members provide maximum strength for long spans, commonly used in basements and where significant loads must be carried. Support post systems, post columns, and pockets. Solid or built-up lumber posts must bear fully on the beam above the foundation below. Check for crushing, rot, or inadequate bearing surface. Usually we'll see the wood post in the older homes, like Jim said. You might see a cedar post. Wood is just not the product of choice, but they are now allowing you to use the engineered lumber as columns as well. Adjustable or fixed steel columns, often called lolly columns, verify proper sizing, plumb installation, and adequate top and bottom bearing plates and connections. And foundation pockets recessed in the foundation wall designed to accept the beam ends. Check for minimum 3-inch bearing depth and proper clearance from the pocket walls. I think we're going to get into the adjustable jacks here in a second. So span and deflection, recognizing problems, understanding deflection. So that's kind of what I was talking about when I was walking through that dining room and the dishes were shaking. All beams deflect under load to some degree. Excessive deflection indicates an undersized beam, overspanning, or deteriorated conditions. Code typically limits deflection to L 360 for floor joists, where L is the span length, the length divided by 360. Visual indicators, noticeable sag when sighting along the beam's length, cracks in drywall above or adjacent to the beam, sloping floors in areas supported by the beam, doors and windows that don't close properly. Some deflection is normal and expected. Report concerns when deflection appears excessive or is accompanied by other distress indicators. So if you look at, I think the next, could you just pop to the next? All right. One more, Jim, for a minute. Wasn't there a bigger picture of that deflection in here someplace? There it is. Okay. So the load in the center of the, we'll stick with beams, will put stress on the, it will compress the top fibers of the wood and stress the bottom. It put tension on the bottom. So there's a couple forces working here. And if that was an overspan, then the simple, and it's not that simple, because once that settles in, everything follows it, but you would put a column underneath there, at least to prevent it from moving anymore. And if you try to jack it up, you got a whole bunch of different problems. But if you look at these pictures, the shorter the span, the more weight you can put in the middle, the longer the span, the less. And that's why we need those columns downstairs to transfer the load from the beams in the proper locations to the foundation. And don't forget that there's pads underneath the slab. So if you move or add a beam, you should be putting in a pad underneath the slab as well. If you think there's a load and you want to compensate for it, it should have a pad under the slab, or the slab could crack. Okay, Jim.
You want to go through these or just skip
Yeah,
ahead?
so, we want proper connections on whether it's wood or steel where they meet the beam. So wood on wood, minimum 1.5 inches bearing for dimensional lumber, 3 inches preferred for engineered lumber like LVLs. Wood or on masonry, minimum 3-inch bearing depth and foundation pockets. So that's into the foundation, with 1/2 clearance on the side and the end. So we don't want it. Don't forget, everything expands and contracts, and also moisture. So we don't want it right up against the concrete. Wood on steel, full bearing on steel column cap plates, verify proper fastening and load alignment. And steel on foundation, steel beams required, adequate bearing area on masonry or concrete, minimum 3-inch bearing length. That might not be a great picture. That's kind of a massive base there. Warning signs of beam problems. I think when we walk through a house, we can feel all this stuff as we walk, but unless you got Frankenstein boots on. But you'll have separation of the floor dropping perhaps away from the wall and the baseboard. The doors will rack in some areas, especially the closer to where the problem is. So these visual indicators often point to beam issues. Cracked drywall suggests movement or deflection. Misaligned doors indicate settling or inadequate support. Floor dips reveal insufficient beam capacity and crushing at bearing points showing overload. Document all observed conditions with photos and measurements when possible. So viewing code, if you're viewing this as a pre-recorded webinar, LVL4234, send both codes to us and you'll get your certificate. So undersized beams, as we talked about before, they will sag. A lot of times, especially in those cottages, they're all undersized, and you'll start to see things get pushed back into position and shimmed up. Beams that are too small for the span or load will deflect excessively. This is common when homeowners replace bearing walls without engineering calculations. Look for visible sags and floor movement above. Missing support post. I see this a lot on decks. This occurs when beam spans beyond the capacity without intermittent support. The beam may appear adequate, but spans too far between the posts, resulting in excessive deflection or failure over time. The most popular, keep your eyes open when you see a pool table in a basement. A lot of times these columns get taken out to fit the pool table in or furniture. Be extra careful when the basement's finished. Most likely things get moved. Inadequate connections. And, Jim asked, saying that the wife is the one that asked if she could remove a wall. Well, the husband's the one that wants to move the beam for the pool table, the column. So
Yeah.
improper fastening or support beam ends lead to weak points. Look for beams resting on inadequate bearing surfaces, missing hangers, or insufficient fasteners at connections. And unauthorized modifications like holes drilled for utilities or notches cut for clearance can severely reduce beam strength and load capacity, especially in engineered lumber.
So,
Okay, Jim.
just for our newer members, the codes that we're talking about is if you're watching this as a pre-recorded event. So like tomorrow, this is going to be posted for people who missed this. They can watch it and submit the codes. If you're watching this live, you do not have to submit any codes or anything. You're going to get your certificate tomorrow.
This is a situation where the slab was actually getting undermined by water and everything was dropping. So they kept on adding a piece of paver and steel to shim that one up. This on the right is the beam in the garage that's just toenailed into the center post.
Yeah, there's nothing holding that.
There's nothing holding that. Now, not
Why
much of
wouldn't
a
they just
load, but
couldn't they have just notched this out?
um,
Because even if you put brackets there, would that be enough? Because the bracket would be holding the whole load.
well, honestly, I don't know if they make a bracket. It'd have to wrap around there, right? Because there's no space to nail it off
Right.
like a regular joist hanger. I'm
Right.
sure there's a bracket for that application. And that garage was probably, it was older and that wasn't going anywhere, but that's not the right way to do it.
No.
So modifications and risks. The most dangerous mistake homeowners make is renovating load-bearing walls without installing adequate beams. This creates a immediate safety hazard as loads redistribute to remaining structural members, often overloading them beyond capacity. I'm going to say, if you encounter an opened wall area with no visible beam or header, this is a critical finding requiring immediate referral to a structural engineer. We're not going to see that often, rarely. Document the condition thoroughly with photos showing the open span, any visible deflection, and the supporting structure above and below.
We do have a question that many cottages have crawl spaces with no basement that have posts sitting on a concrete block rather than a concrete pier. Everything seems stable. Do you call it out or not? So if everything looks stable and proper and even and plumb and level and well supported, I don't call it out. But I just ran into a situation out in Litchfield where I was in that crawl space and everything was slanted. The agent told me that everything had been repaired, that the homeowner had repaired it. And I was like, yeah, they didn't. What they did was they just took some concrete block and put some wood and tried to stack it up. And it was all uneven and there wasn't really good support. Remember, in a crawl space, there's limited freeze and thaw. So you don't necessarily need 48 inches into the ground like you would the foundation. So I don't know where you stand on that, Stan.
And I'll add to that. So
Sure.
I'm on the shoreline in Connecticut, and I've been in thousands of these. And I let my clients know that most of these buildings were seasonal in the beginning. And a lot of times the foundation walls were added, so at one point in time you could roll right underneath these right through and come out the other way. And also make them understand that probably the rest of the house is under frame by today's standards. And I tell them when I see, and that's, a couple blocks with some wood shims, just you see everything underneath these things. And if, like Jim said, if there's indications upstairs that there's issues, then I will tell them that this should be better supported. If I think everything's fine and it's okay, I will tell them there's better ways to do this and they should consider it. It's a lot of work replacing all those things the proper way inside a crawl space. It's expensive, and most people just let them go until they have an issue.
And the other thing too is I've always found, and if there's a question in your mind, call it out. You can
Yes.
always write it up to say, I noted supports in the crawl space that appear to be undersized or undersupported and not to current standards. I recommend a licensed contractor go out and evaluate. Then at the inspection, you're telling your client, listen, like Stan said, all these cottages were built in the 40s. They weren't meant to be lived in year round, and they don't have the pier 48 inches into the ground. Everything looks good to me. I was upstairs. We jumped up and down. It seemed okay. Everything looks nice and even. We're probably okay. But if they were build a house today, they wouldn't do it that way. So you got to judge your client a little bit. But at the end of the day, if you are unsure about something, call it.
Write it up.
Because that can only help you.
So cutter notch joists, structural weakening, holes too large, exceeding 1/3 joist depth or located outside permitted zones, notches in tension zones, bottom edge cut that severely weakens the member, multiple compromises, several cuts or notches in the same joist, cuts near supports, modifications with critical bearing areas. These modifications often made to accumulate plumbing or HVAC, and I think we've all seen it probably quite a bit, depending on how long you've been in the business, can reduce joist strength by 50% or more. Recommend evaluation by a structural engineer when you observe significant alterations. So here is a little bit of a diagram. So no notches, middle third of the joist span. Hole diameter maximum 1/3 of the joist. Notch depth max 1/6 of joist depth and max length 1/3 of the joist depth. The holes minimum 2 inches from top to bottom edges from other holes and from notches. No notches anywhere in the bottom edge except at the ends. And notch at the end, the maximum depth is 1/4 of the joist depth. Now you'll see maybe on the next page. Go to the next slide, Jim.
I'm going to, one thing, Matt, if you can't hear us, you can try logging in, but it usually is just your volume setting. Turn up the volume. Go ahead, Stan.
So this obviously is, best as I can tell, 50% through that floor joist.
Easily.
And so you've kind of just taken that, let's say it's 2x8 and turned it into a 2x4, basically. And if two of us jumped up on top of there, we'd probably crack that. And these guys here too. I mean, if your span called for a 2x8 and you cut half of it or more than half of it away to notch it, that the strength of that floor joist has been dramatically reduced. I had a person that, well, I'm going to call them a friend. I haven't seen them in 30 years. We coached baseball together. They're selling their house, and they're in a 1910 house here in Milford, and all their floor joists were notched like that on a mini ledger board that was on the main girder, and they're all cracked. Like, not all, 30% of them are cracked at the at that cut, that notch. And they've been there 35 years in that house, and who knows when those cracks developed, but that's just not a good thing in my opinion. So if it looks temporary, it probably is. These jack columns are meant to be permanent, I'm sorry, temporary or for construction purposes only. While you're building, you can have them underneath, and then you should be putting a permanent column in, proper column in. And I can't find any documentation that says that they could be used as permanent columns. Although the kit homes that I was referring to before in here in Sonia have these from day one. They're only ranches. They probably are doing the job properly. I always recommend they should consider putting concrete fill steel lally columns in. Do they really? What's that?
Go ahead, Stan. Sorry.
Do they really transfer the load properly? In the ranch, there's hardly any load. They probably can't.
So, Stan, we got to move through. We're at 8 o'clock, so just to let you know.
All right, so here's one that I've found over the years as well. Sometimes the partition wall, or it should be over a floor joist. Sometimes the partition wall is put in the joist bay, and it will sag, and the doors will rack. And it's kind of difficult to correct that. So we're a little, go ahead, go to the next one, Jim. So this is what will happen. You'll get some cracking in the wall, the door racks. You know, another reason that's from settlement. All right. Another reason why a door may stick, if you don't see any cracking, the floor seems pretty level, is just poor installation of the door, or the hinges are loose. So first thing I do when I see a door sticking is I grab the doorknobs and lift the door. If it moves, sometimes I may even try to tighten the screws for the people, and they think I'm wonderful. But sometimes the screws are so small that you need to put longer screws in. But most of the time, it's a structural issue. So homeowner renovations, when to defer to engineers, when the alterations require knowledge of load calculations, material strengths, or structural analysis beyond visual inspection. Any condition that presents immediate or progressive structural hazard, this is not the time for gray areas. When you cannot clearly trace how loads transfer to the foundation due to modifications or unusual framing, and that's probably us if everything's finished. And significant structural changes without permits, plans, or engineering stamps require professional verification. And that's how I cover my butt. Homeowner in a 1960 ranch removed a central wall to create an open floor plan, installing what they believe was an adequate beam. Within 6 months, progressive sagging appeared in the ceiling. Doors won't close, and cracks spread across the walls and the ceiling. The problem, the installed beam was undersized for the 18-foot span and lacked proper support posts at midspan. The beam deflected over 2 inches, overloading the floor joist above and causing widespread structural distress. The structural engineer specified a properly sized LVL beam with intermediate support posts requiring temporary shoring during installation. Repair cost exceeded $15,000. 10 times the cost of doing it right initially. So the inspector's lesson, this failure was preventable and entirely predictable. You can observe and clear reporting protects homeowners from these expensive, dangerous mistakes. So interior walls appear to be load bearing based on particular joist beams, joist orientation and alignment with basement beams. I don't know if we need to go through all that. I mean, if everything looks good, then wall alterations observed with no visible support beams. Recommend evaluation by a licensed structural engineer prior to closing. Main basement beam exhibits noticeable deflection exceeding typical tolerances. Cracking observed in drywall above the beam on the main floor. Recommend evaluation by a structural professional to assess yada, yada, yada. Floor joist and basement show multiple large notches and holes that appear to be to exceed code permitted sizes and locations. That's probably one we're going to see quite a bit and should be called out every time. So visual assessment only, right? We are only looking at what we see. I know a lot of home inspectors like to try and go beyond that. I think you open up a proverbial can of worms in that case. If you see issues that you believe could be problems, just write it up and pass it on. Your inspection should always, whether it's your agreement or your inspection itself, should always indicate the limitations of what we're doing. no matter what we're looking at. It's a visual assessment only, and anything beyond that needs to be done by a contractor. So comprehensive photos, photograph everything that you think is an issue, label the areas
Indication.
just in case they're unclear in a picture, use arrows, circles, or text overlays to clearly identify the issues in the photo. Measurements when possible. You can record beam spans, deflection amounts, opening widths, and other relevant dimensions. I think a verbal or in writing would be enough with the pictures. Specify exact, if they're visible, if you can see them in the picture, and specify exactly where issues exist using cardinal directions, room names, or distances from reference points. Defer to qualified professionals. Got to keep that safety first in mind. Your most important job is to recognize the problem, and your expertise and telling somebody how to fix something exceeds your expertise and requires special evaluation. Recommended phrases, recommend evaluation by a licensed structural engineer, further investigation by a qualified professional is advised, structural assessment recommended prior to closing. This condition exceeds the scope of a home inspection, defer to structural engineer. So all those things are different ways of passing on to somebody who can figure things out. That's their job.
That's
So
fine. This is just a checklist.
we talked about all those things several times.
Okay. We got through it. So, Stan, anything further that you have?
No, I think that it's good to know how to, if you had everything open and you can access all the framing, it's good to know how to follow the load path. If everything is concealed, you have to be able to identify things that could be a problem with bearing or load paths. And that's kind of what we're talking about. You have to look around. If you think the house was modified, you got to be extra careful, even when an addition ties into the house, because it puts a load someplace. And then report accordingly.
Okay. So I'm going to wrap up the recording right now. So